Uh,
Mary Lou,
Carry on.
I'm sending you something in chat. So one thing I saw from that I was thinking of is that there is, from what I can see, a lot of information for people that have not done meteor scatter. A lot of what I looked at was really not for somebody that is not familiar with the digital modes or has not done it before, and that there was a lot of different sites. And sounds like Rich was just bringing up one place, but I feel that one thing that would be important is that we consolidate and we don't have like a list of saying, if you want to learn about it, here's all these sites, or here's all these papers, or here's all these presentations, but that we try to consolidate. And for the ham radio operator that we want to bring in, that is new to HamSCI, new to Meteor Scatter, that we have something that is easy for them to find and thorough, starting from the assumption of you know nothing about it. And so that for people like myself, I'm already mentioning this. And if I do any presentations, that we have something we can send them to so that we have something for both the experienced person and we have the new person that we can guide and bring in and do it. And I think you've already talked about that a little bit, but I think that could be really important to expanding our our participants.
That was my general thought on some of the things that I sent in with the notes on the Google site, because you folks are going to be designing a meteor scatter contest, and most of you never operated meteor scatter. So, so if you just start listening, that was my ideas.
Mackenzie and whoever, is this going to be a two-way thing, or just will everybody be just listening?
Well, I don't think we've defined it yet. I think what we're going to do today, what I'd like to do today on the HamSCIence Zoom call. Today is what, March 6th, 2025. What I'd like to do is let's take a look at Mackenzie's proposal for what we want to do, what kind of science questions we want to answer. And then I think over the next few weeks or a month or so, we can start talking about, let's figure out what we want to achieve, and then we'll figure out how we want to achieve it, and then we'll figure out how to document it. I think a lot of this will lead into not only good documentation, as Ron has suggested, which we'll probably put on the HamSCI website, but I think it'll also, it should probably lead to some practice sessions. You know, W3 USR is on the air every Thursday night. Maybe that's an opportunity that they and we and a few of others of us can try MSK 144, because you don't necessarily need meteors to use the mode, as I understand it. If you've got F-layer propagation, we should be able to communicate via that mode. Is that correct?
Some of these sustained modes will give you some data. You're not going to get a steady stream. There's various delay problems. There's multi-path problems, which is probably the bigger of the problems. And sometimes with the F layers, you do get a multi-path issue. But it should work. Yeah, locals will work. I copy locals all the time within a couple hundred miles when they're in the wrong sequence. In other words, they're transmitting when the DX or the distance station is coming through. It makes it kind of difficult to copy, but yeah, I think the locals within a couple hundred miles should work. If you have a reasonable antenna running 100 watts or so, it should work fine.
Okay. Well, like I said, let's kind of hold that off to the side for a moment. Let's make sure we understand what our goals are for doing this event. And once we understand the goals, then we can work on the how to make it happen. I did some look at PSK reported some of the MSK 144 numbers, how many spots we've got, and what I found was, to me, was kind of astounding, but I'm not 100% sure it's accurate. But we'll get to that later. And Mary Lou's got some information too on some others that have done meteor shower observations via radio. So we got a couple of things to get through yet today. Mackenzie, would you like to bring up your poster, and we'll briefly look through that? I really want to focus on those science questions, because Mackenzie's going to print this poster up. We're going to have it at the HamSCI workshop next week. I'll probably be standing nearby, looking for questions and answers, and seeing what we can we can learn about from the attendees next week as well. So there you go.
Can you see it?
Yes.
Yep.
Okay. Let me move my window over here. Okay. Let's see. So everything that's in red has been added recently. I know Nathaniel suggested adding some figures, so I did over here. This one is PSK reporter, showing MSK 144 reports, and this one is actually the waterfall that he suggested as well. Let's see. Okay. Oh, no.
I've got some more pictures you might want to put in.
Could you please send those to me?
Well, yeah, I'm going to give the presentation pretty soon.
Okay.
Then I'll send it.
Thank you. Okay, so these are the questions right here. Kind of glitching out for me for some reason. Can everyone see the poster still?
Yep.
Can you
Okay.
make it bigger?
There. Okay. So these are the open questions that we're trying to figure out so far. The first one says, what is the typical duration of HF meteor scatter reflections, and how does it vary with meteoroid size and velocity? So let's see. Does anyone
So
have any suggestions?
Yeah, so the question is using spot data. When we know we've got typical spot data, we know the transmitting station and receiving station, their locations. We would know the time of the contact, and also, of course, the frequency. And with those bits of information that's in the spot data, which would be typical what you get out of WSJT when you're creating an ADIF log or uploading to PSK reporter, can we think we can come up with things like meteoroid size and velocity?
Maybe I should show you what I found already that people have come up with, and then we could restate it for this.
Okay, I
Sure.
can stop sharing if you want to take over. Okay. There we go.
Okay, so. Okay, so this is just very, very quick stuff I looked up this morning. So it's just a very beginning of things that might bear on what we're doing. So stuff, okay. First, I think you should look at the International Meteor Organization, which is Europe. There's another one in the United States, but this one in Europe sounded interesting. So it's www.imo.net, and then they have resources, and among the resources, they have a calendar. So that's an interesting part, because I suggest that these are the meteor showers that are coming up between now and the last one, which is in red, which is the Perseids, August 12th to 13th. And the moon is nearly full, 84% full. So the interesting part about this, I think, is that they have 1, 2, 3, well, 3 and 4 are on the same night. So there are 3 specific nights where they suggest there are going to be lots of meteors. So we ought to have some sort of practice sessions, at least on these 3 nights. Okay. Now, the reason that they have the part about the moon is that most all the people in this IMO group look at the things in regular light. So they have either binoculars or their eyes or a telescope or a camera. And what they're doing is visual. But the moon is a great big spotlight in the sky, and the moon is their mortal enemy. So the moon, they always talk about the moon and what the bad thing the moon is doing. So the best one here is the second one down, where it says the moon is already set. Yay, it's not even in the sky. That's the one that the visual people will be out all over the place. And the top one, crescent moon, really tiny, not to worry. But look at the Perseids at the bottom. The main one, biggest one of the year, August 12th to 13th. The moon is nearly full, 84% illuminated. It's going to shine like crazy, and it's going to mess up the visual observers, something awful. So this year, if we could do something with radio, which doesn't care about the moon, then we'll be golden, because the visual people are all messed up already and they know it. Okay? All right, so this is just particular days on which traditionally there are lots of meteors in the sky. Okay, the name that is given to them, like the first one is Lyrids, has to do with what constellation you look at in order to see them coming right at you. So that would be Lyra or Lyra. And we could find in a map of the sky where that one is. So you would say, okay, on that night, Lyra is over there. So that's where the meteors are going to come from. But I suggest, like they do in the visual people, you don't look right at that position because you just see a little dot coming right at you and it's really tiny. But if you look sideways to it, maybe even 90 degrees away from that in any direction, 90 degrees, then you see a streak, and the streak is what you could bounce stuff off of. All right. But at any rate, so they have different names because that's where the point that the meteors appear to be coming from. And that's called a radiant. I mean, they appear to radiate out of that point. So I think it's interesting, something I didn't know before, is that number 3 and 4 here, the Southern Delta Aquarids and the Alpha Capricornids, are both on the same night, but they're coming from different constellations. So the Aquarids are up here and the Capricornids are down here, and this group is going like that, and this group's going like that. And so you could see, and that would be really interesting to see if we could figure out which one is coming from which one. I don't know. So the people who do visual meteor trails stick a camera up there and take a long exposure, and they see some lines going this way and other lines going that way, and then they could identify which one was coming from which. But then again, if the moon is a problem, they can't do that either. So anyway, so I thought this is interesting. So I'll send this to Gary. He'll send it out to everybody.
A comment regarding overall meteors and what individuals will see or hear in the areas. Meteor scatter, the meteor burnout is at an altitude of hundreds of miles, or it could be 100 miles or so. That means there's very much like the E-skip layer. There are stations, there's a cloud at the midpoint.
Oops, we lost your audio, Rich.
Okay. Hello. You still copy?
Yes, there you are.
Okay, there you go. I don't know what happened here.
Get
Let me
it
see
back.
if I got something loose here. All right. The meteor burnout will have to be at a midpoint. If you are in New York and there's a station down in Georgia, that burnout will have to be on a line that's perpendicular to those two locations. And stations closer, say somebody in Philadelphia trying to hear that station may not even hear that same station on that particular meteor. It's not going to, we've had occurrences where there, in this area, in the DC area, I live in Virginia, there are dozens of stations. Many of them work meteor scattered at the same time. Some of them are distant by, separated by 50 miles. And there are times one station will hear a burst, the other station will hear nothing. So it's difficult. It's going to be difficult to number one, identify where the meteors are coming from. I don't think you're going to be able to do that at all. But remember, for a meteor burst, stations that are maybe 25, 50, 100 miles apart are going to have different results. There's not going to be, there's very rarely the same burst will produce contacts between multiple stations. Just because you have to be, it can be very selective. The burnout it has to be positioned in the sky in just certain location in order for you to make a contact with another station on the other side of the meteor by almost equidistant from the meteor burnout to you and meteor burnout to that other station.
I have a question for you, Rich.
Sure.
If you have normal radio, like, or whatever you have, it has some sort of cone of antenna pattern. What sort of angular size on the sky can you see?
Well, I normally, with the Yagis that I use on 2 meters, well, let's say 6 meters. I use a 7-element Yagi on 6 meters. It has a beam width of 3 dB points of maybe 25 degrees either side. At that point, after that, it starts dropping off. Again, there's a
So
vertical
does
angle as well.
that means that you can see a place in the sky and 25 degrees here and
Either
20.
side at the same,
That's pretty big.
within a couple dB of each other. Now,
Yeah, so it's like
as the
50
meteor,
degrees wide.
yeah, as the meteor leaves that my beam width, I can probably still hear it, but at a lower level. Now, also you have the vertical angle. A Yagi, a multi-directional, multi-element Yagi, has a vertical pattern as well. Meteor is coming down. It's coming not coming. It's coming down from a high angle to a lower angle, and if it's too high, you're not going to hear it. Once it gets down within maybe 30 degrees above the horizon, you should hear it fairly well until when it leaves and or crashes to the earth.
So how big is the vertical beam? Is that
It's
50
about
degrees wide too, or much
yeah,
smaller?
about 30 degrees again on the upper side. On the lower side, of course, you've got the earth, and then you have reflections. The signal may come bouncing from the meteor to the ground and up. Uh, anyway, but let's not talk about that. So you could have too sharp an antenna, and you may not hear as many meteors. On the other hand, say you're using a dipole, the simplest of antennas, or vertical, you will hear more signals, but the intensity of the signal will be much weaker. If you're masked by noise in your local area, you may not hear the weak ones.
Okay,
So
yeah.
okay, so it's a compromise between gain. If you're going to build an antenna or get any kind of a Yagi for 10 meters, for probably for 10 meters, a dipole will probably work for most people's tests. So get a dipole, get it up 20, 30 feet, and in the clear, and you should do well. Especially since as they said, the meteors will be much longer in duration. The burnout will be much longer in duration than we'd typically hear on 6 meters, about 4 times as long. And by the way, people are using meteor scatter in some of the HF, for instance, the 10-meter contest in December. People use meteor scatter at dawn for a couple hours and make contacts that way. And the bursts last for could be 5 or 10 seconds, enough to make a quick contact. But you have to be on the ball and to catch those and harvest those very sharp, very small burnouts.
Sounds good. So let me show you this slide here, which shows the geometry of the situation. Even though they tell you in the calendar that the meteor shower is the night of blah to blah, the best time is at dawn as you're going into the second day. So here's a picture of that. We're looking down at the Earth, and in this weird picture, the sun is down below, but much smaller. Whoever drew this one, anyway, it's certainly not to scale. So there's the sun down there, and there's the Earth above, and there's this huge person standing on the Earth, right? And the person is on the nighttime side. That's the half of the Earth facing away from the sun. The meteors are these little blue dots, sort of at the left-hand side there. Okay, so the actual meteors are bits of leftover comet debris. So they're pebbles down to grains of sand sort of thing, and some of them actually really dust. But anyway, there's a bunch of them there left by a comet that went by some year before. The Earth's orbit in this case is the line going toward the left. So there's a blue arrow there, Earth's orbit actual motion, 18.6 miles per second. So we're heading leftwards across this screen at this whomping big speed. Because the sun is down below here, we could say there's the sun. We're going leftwards. We're going in a big circle around the sun that takes us 365 days to complete. And if we look down, we're looking down from the North Star, from the North Pole. So a circle going leftwards around like that is called counterclockwise, right? Okay. Everything in the solar system goes counterclockwise. Everything. Well, pretty much everything. Some comets are weird. But at any rate, so then we look at the Earth itself, and there's day facing the sun and night facing up here, and this huge person is at night. So if everything in the solar system goes counterclockwise, the Earth itself turns counterclockwise like that. So we go from the word equator to where the person is. Can everybody see that the Earth is turning in that direction, counterclockwise? So that means that this person is being carried by the Earth left and down a bit. And now pretty soon he will be facing into the stream where the meteors are. And if they're just sitting there or going at very low speeds, whatever, the Earth's orbit will then take him right into that cloud of meteor debris. So that is the best time you're going forward into the debris is where the Earth's orbit arrow is. So that's dawn. That's the transition from night going into day. So that's the best time. So I don't know, 4 o'clock, 5 o'clock, 6 o'clock, whatever it is, 7 o'clock, 8 o'clock, whatever dawn. So mostly 6 o'clock in the morning, local time, is when the meteors will be best. So the people
Mary,
visual do it before dawn because they can actually see stuff, but radio could see it past dawn as well. And 7, 8 o'clock in the morning is just fine. Yes.
yeah, I was going to say that's holds true for random meteors. There are showers that occur that they'll peak late morning, early afternoon. I would suggest you download a program called Virgo, VIRGO,
Okay.
VIRGO.exe, written by DL1 DBC. Plug in your local latitude and longitude. I think they do by grid square, and it'll tell you for today's date every meteor shower, if they're major or minor. They'll tell you you have two variations, either two options, either direction of the meteors or the direction of your beam for for best signal. So
Great idea.
Virgo.exe.
Okay. All right.
I'd like to also add that time is a consideration in that if you get up at 4 a.m. on the East Coast and your signal lands one time zone to the west, you're going to be all alone.
That's true. They'll be sleeping. A lot of guys
Right.
on random, but on showers, you'll find guys up in the middle of the night, all night, trying to harvest those meteors.
Usually around 7 to 9 in the morning is the best I find. And usually by 9 o'clock, everybody's going back to bed or going off for the day.
Very good. Yeah, so if it depends on another person, as well as depending on the meteor, then the other persons become maybe the limiting factor, right? And 7 to 9 a.m. is good for them, right? So I thought I'd tell you this thing because I had never even heard of it before, but it popped up. I don't know. I want to know if anybody else has ever heard of BRAMS. It's a different radio method. The B is for Belgium, so it's Belgium Radio Meteor Scatter Group. They do specular reflection, which is forward scatter. They have one transmitter in the south part of Belgium, and 44 citizen science receivers scattered throughout Belgium. The transmitter transmits at 49 point something or other megahertz, and these 44 citizen science receivers are evidently on all the time, and they listen for this. It's circularly polarized. It's a particular thing that they can look for that's not another person. It's just this one transmitter, which is on all the time. They get sudden blips, really short, and they send all this information to the head of the group, who puts it in a MATLAB solver, and they solve for the meteor's trajectory, and they are pretty much limited to, as you said, 80 to 120 kilometers altitude, maybe a little bit above that. And the velocity of the meteors comes out to be always between 11 and 72 kilometers a second. And they solve for, as best they can, for where these individual meteors are coming from, so they get an actual vector in the sky and a velocity that it follows in the vector. They have found that they wish they had more information, and so now they've got an interferometer since last year, and they're going to have another interferometer in the north of Belgium. At any rate, if you have a little bit more information, you can not only find the direction that these meteors are coming from. So this is one of the things that is a science question. Where are they actually coming from? And it's not exactly from the radiant, but where exactly it is. What is the velocity of the meteor, if one could find that? And what is the deceleration? Because it's rubbing on the atmosphere as it comes in and slowing down. So these are some of the science questions that these folks in Belgium are trying to answer with their method. Okay, so here's another group. This is a group from Japan, Ogawa and Sugimoto. And this is last year's 2024 Perseid data from them. What they have found is, and so this is visual, and they have data sets of people all over the world that send them stuff. And what this is basically is, so solar longitude is basically time or direction in the sky. And what we see in this one, so the top is the more real data, raw data, and the bottom is more smooth data, that the number of meteors in this particular shower was low. It went up in the middle and went down on the right. So there was a period of some hours there in which there were lots of meteors. But what they found is that there were 3 peaks within that. So I think that's another thing we could look for. And this is called streams within the shower. So the dust and the debris shed by the comet was not uniform, not like cars on a superhighway, but rather there were clumps of them, and there were 3 separate ones, and that's interesting for how the comet itself is breaking up. So thought I'd
Mary Lou, I have a suggestion for those who own a software-defined radio, an SDR. There is a continuous carrier or carriers from up in Canada on 55.250. It happens to be their TV channel 2 video carrier. It's a great way of monitoring meteors throughout the year. Tune your SDR to 55.250, put it in the upper sideband or lower sideband mode, tune to 250 or 255. They could be offset plus or minus 5 or 10 kilohertz, but you should be able to see them on the waterfall. And if you tune within a couple of hundred hertz of it, you'll actually hear the burst of the pings or the long tones for the longer bursts on the TV carriers of the Canadian, the few that are still left, analog TV stations up in Canada, 55.250.
Great. Good for the Canadians. All right, so this is just another science question, and that's it. Okay. Back to you.
I think that was pretty helpful. Mackenzie, what'd you think?
I also, yeah, I agree.
Things you could list down there, whether we could do them or not. They're interesting things people want to find out. Okay.
I love those passive radar ideas. That TV channel really sounds interesting.
Yeah, yeah.
It's always there until they take it all down and go digital.
Is it way up in the woods, or where is it coming
No,
from?
they're within range. A lot of a number of the locals here, they'll tune in and we'll just kind of compare notes as to what we're hearing. And you can tell when the meteor, you can record them. Yeah, you could count them manually, how many pings you get per minute, and you can find when the showers peak that way. It's always from the same direction. Again,
Where are you located, Rich?
I'm located about 50 miles west of Washington, D.C. in a
So
town
Washington.
in Culpeper County in Virginia.
Okay. So we could hear Canadian television all the way down to Virginia. Cool.
That's the video carrier. All you hear is it sounds like just a continuous tone. If you're a local to it, it would just sound like a carrier. That's what it is. It doesn't have any data on it, just the base carrier.
The carrier, okay.
So thinking about some of the science questions Mackenzie proposed, it sounds to me like she was on the right track. So my question is, what's a good approach for us to try to reproduce some of these other teams' results? Or do we need to look for new results? Or do we just get the data and then go from there? What should our approach be?
Well, take as much data as you can, but I think try first to duplicate what some of these other people are doing to calibrate the method.
You have to have source signals. You have to know where the sources are. If they're call signs that you're copying, you can check qrz.com. You can get a grid square, a lat lon. So that's one piece of data you can use. And you're going to be receiving stations from anywhere between 500 and maybe 1,300 miles. You will not hear anything. You'd hear very little other than the locals on the short distances. But just like HF, there's a dead zone between, say, the end of your local range and the minimum skip zone. And it takes a much more intense meteor burnout to get a short skip, just like it does in HF. Uh, when you have a very intense 6 meter signal, so the short skip on 6 meters may be 150 miles, which is very unusual. On 2 meters, you might have for that same midpoint. That'll be a great highly ionized spot for a station that may be close to 12 or 1,300 miles apart. Again, with that burnout being at the center. So what you hear is going to depend on the intensity of the meteor. The greater the distance, it'll take a higher burnout. It'll take a more intense meteor. And then don't forget you have that short skip zone. So basically, you need to know. I think the best you can do is listen on a ham frequency where you know there are people that are going to be transmitting, such as 28,145. There's not going to be a lot of them there unless you get the word out to the meteor crew, those who do meteor scatter. Most of them will be on 6 meters. They'll be on 50.260. Some will be on the 2 meter frequency, 2144. I believe it's 150. But you're not going to have that many out there on 10 meters unless you put the word out in sufficient time. And then the best you can do is just copy the calls, look up the grids, get the distance, figure where you are. Then you can pretty much figure out where the midpoint is.
Well, let's
Let me throw a couple of comments in here, please, Gary. This is
Sure.
Bruce. So earlier today, I sent a note out to the Front Range 6 meter group, who are very, very active. Rich and I work with them all the time. And I got some pretty quick responses on interest in doing some experiments on 10 meters. And I mean, my take on everything we're trying to do here, and correct me if I'm wrong, Mackenzie, is we're really trying to see if, partly through an educational process to get people involved in 6 meter, but also take advantage of the new 10 meter legal capability to do MSK 144, and then make some comparisons on numbers of contacts, et cetera. So I did contact the group. There's a lot of interest. I put a comment up in the chat to plan for the April event, the LYRA. It's a great idea to think about LYRA in April, to get enough folks involved in thinking about 10 meters to pick a time and we can probably get, I don't know, several tens of people or 50, 60 people potentially to participate in an experiment as long as we publicize it the correct way. So that's kind of started, and if everybody agrees, I'll take a lead on trying to coordinate enough people to make that happen.
You go for it, Bruce.
Yeah, that would be outstanding. That's the kind of I think support we need to make the thing successful.
If anybody has any other comments, just put them in the chat and I'll take it into consideration. But I think between Rich and I, we have enough contacts to be able to get plenty of folks involved. Rich and I are virtually neighbors here in Virginia. Okay, great, thanks.
Okay, two things. Greg had a good comment there. I'd like to get back to Mackenzie's poster real quick. I'd like to show something on my screen real quick. I've done a little bit of looking at PSK reporter data. And I think many of you are familiar with this, where if you go into PSK Reporter, I picked a particular date a few days ago. I just wanted to contact her in this particular mode, MSK 144, and you get a frequency, or what I extracted from that, a band, the sender, the sender's grid, the receiver, and the receiver's grid. So we, just like we've done with a lot of our other data and other research, we know who's talking to whom and where they're located. I'm not 100. I want to do some more research, do some more work on this. But for instance, back on March 1st, there wasn't a lot of meteor scatter going on apparently. What there were some contacts made on 6 meters and 2 meters, but almost none on 10 meters, which is not a surprise. Let me see if I can find my keynote here. So the other thing I looked at was August 12th of last year, right in the middle of the Perseus. And I looked at how many spots were on MSK 144 on that 24-hour period, and I came up with 1.2 million. Yeah. My method only allows me to look at a million at a time, but you can see that 67% of them were on 2 meters, roughly 30% on 6 meters, and next to nothing on 10. So all I'm saying is there's a huge opportunity here to do something on 10 meters that doesn't look like we've been too active before. So I need to I need to look at a few more days. I'm not looking at these 2 data points and saying that's a definitive data set, because I want to make sure there's no confirmation bias in that, among other things. But
Before
yeah,
they
there's some
changed
interesting
the
stuff.
before they changed the MSK 144 big bandwidth, we tried like JT9G fast on 10 meters, but we ended up getting terrestrial contracts, and it didn't work out too well. So I think this is really an open door with MSK now for 10 meters to give it a try.
So just to remind everyone, what Joe and Rich were talking about, at one time, our regulations in the US at least prevented us from using MSK 144 and 10 meters. There was a baud rate limitation and some other things. And the FCC changed that rule approximately a year ago. And we now can use anything that has a 2.8 kilohertz bandwidth and is documented in the public domain. So that's why we now have this opportunity to use MSK 144 that we didn't in the past. So that's thank you, FCC and the ARRL for leading that effort to get the rules changed some time ago. Mackenzie, do you want to put your poster back up? Let's look at those science questions again, because I think we've learned a heck of a lot in the last half an hour.
There we go. Can you see it?
Yep.
Okay, good. So the first one seems like a good idea. Second one, how large is the ionospheric region affected by meteor scatter on HF bands? What do we think of that one?
So my question there is this really an ionospheric propagation mode, or is it really is it the meteor trails that are providing the reflective surface, or is it some of the layers in the ionosphere? So that was I was wondering about this one.
The burnouts occur at the same layer, around the same area as the E layer.
Yes, but take out the word ionosphere.
Okay.
You do see some shifts in the patterns of the meteor. So depending on where the showers come in, but yeah, I agree, take out ionosphere.
Good, thanks. That's very helpful.
Mackenzie, could I ask a question, Mackenzie?
Yes.
Yeah, hi, it's John Campbell. Sorry about my bad camera and everything. I am a ham, currently W3 MHZ Esther class. I went to UPenn long ago. I did want to ask a question formed as a statement, really. I looked at your slides last time, and I know Nathan from W3 USR. Your slides really helped me to get very far very fast, really conceptualize it. So big picture, your slides were awesome. I would like a copy for Penn, W3 APT myself, but we're going to pick here, whatever. I did want to introduce myself. I am an Astra class since I was 12, but your slides were really amazing. They really helped me just conceptualize it, get very far very fast. So I again want to thank you. on my own behalf and Pat's behalf. Please send me a copy of your slides, and thank you, Mackenzie.
Of course. Can I get your email, please?
Yes,
Or
J.
can you put it in the chat maybe?
Yeah, I'll put it in the chat. It's J. Thomas Campbell, Yahoo. But Nathan certainly has my email, W3USR. But
Okay.
I will ping you. But you work with Nathan, right? Scranton.
Yes.
Nathan
rem-
has some emails for me, but I will ping you in the chat. Thank you very much,
Cool.
Mackenzie.
Yeah, thank you so much. Nice to meet you.
So just as a general notice, this poster and almost all of the posters that are going to be appearing at the HamSCI workshop next week will be available on the HamSCI website within a couple of weeks after the conference. So we have an opportunity there as well. So
Right.
you want to continue on, Mackenzie?
Yes. So I did take out the word ionosphere. So is that acceptable for everybody? Okay, good. All right, the third one, it says, what is the relationship between meteor size and the strength of HF meteor scatter reflections?
The bigger
I
the
think we kind
better,
of
the
talked
bigger the
about this,
stronger.
right. I think Mary Lou kind of touched on this.
Well, but I found some variable stuff I didn't write down on this one. So one of the papers I read said that what you're interested in, well, they didn't know, but what we are interested in is not the meteor itself or the meteoroid, which means a tiny one. What the meteor itself is doing, but how much it sheds as it goes and gets broken up. And they said that they felt that the ones that were small in size to begin with shattered more easily and made a bigger trail, or a thicker trail, although it was short. And then the ones that were larger chunks broke up more slowly and didn't make a particularly good trail, but it had lumps in it. So I'm not sure how, and I don't remember how they measured how big they thought the meteor was to start with. And that might be hard to come by, but I think I would restate this to say, what does the strength of the meteor scatter reflection depend on? And, which we have above as well, meteor size, velocity, height, whatever, list things there. So one is strength and one is duration. And so maybe
Okay.
this one is number 3 is strength. Number 1 is duration. Maybe put this one above number 2. So what does the duration depend on? What does the strength depend on?
Okay.
What
So
does
just
everything
two
else depend on?
separate questions, duration and
Duration is number 1, but then this
duration.
is
Oh yeah,
strength, and just phrase
strength.
it in the same way.
Okay. Yeah, I can definitely do that.
You
I'll
can
probably do
measure
that
the
offline.
intensity, the ionization by signal strength. How do you measure the meteoroid size? The size itself. How do you do that?
I don't know, but
You're
you
gonna
just
go
put
up
that in
there and
there.
grab with a micrometer and measure it as it's disintegrating?
I don't remember, but this one paper
Yeah.
did say that they thought the little ones broke up faster than the big ones, so they had a way of
Possible.
measuring
But
it.
yet
But I don't remember what it was, so we
yeah,
definitely.
there have been some super burnouts, they say, on 2 meters that have lasted for minutes, super intense minutes on a band that almost never has e-skip, and maybe in the summertime once or twice a year, but during a meteor shower, tremendously, and you would think that they would be, in order to get intense ionization, there has to be a tremendous amount of burning going on, and you're not going to get that from one little tiny meteorite. So I would say the bigger the better, as I said earlier.
Well, that's what we think, but maybe it's not quite true. Maybe there's something in the middle. I don't know.
Yeah,
Maybe the really
it'd be
big one's
interesting to
the
know how they
size of the.
measured, how they measured, how
I
they
don't know.
measured the
I don't know.
size.
I have two thoughts on that. One thought is different meteor showers, the meteors can be made up of different material. Therefore, they have different burnup characteristics. And the other thought is, how do you tell the difference between a meteor breaking up and the intensity of the number of meteors coming in? Like if you have a shower with a meteor storm, all right, how do you know, volume versus how big the meteors are?
Right. Another thing is the speed of the meteorite. You'll find like the Leonids are very, very fast, probably the fastest of all of the meteorites. And then you get the slower ones. Well, the slower ones, since they're going slower, you think that the bursts would last longer, and they probably do. But I remember back in 1966, we had a Leonids, the biggest Leonids ever, and there were thousands of meteorite burns per minute. At best, it was best if you're in like in Arizona, but here on the East Coast, the way it appeared was almost continuous ionization with lots of peaks. Like you'd hear this is all on CW, so you can hear the CW signal, but it would be like bursts on top of bursts when you had multiple meteor burnouts, and there were multiple ones. It was a once in a lifetime type thing.
I remember that too. I was sitting out in the driveway in my pajamas and a parka, on a lawn chair with my family. And it was like going into, like driving through a blizzard in that when you looked up, there were just things streaking at you.
Where were you located at the time?
New Jersey.
Okay.
And so
It
there
peaked.
was
It peaked
like
here,
20 meteors at a time, and again and again and again. It was.
yeah. I wasn't outside. I was experiencing it inside. It was after sunrise, around 7 to 7:30, that it peaked here on the East Coast. I was in Maryland at the. No, I was living in Connecticut at the time, and I never did go outside to see anything.
You
But it
should have
must have
gone
been something
outside.
else. Yeah. But the place to be was out in Arizona. They had the best view and the most meteors.
But the Leonids are known to have a big peak every 33 years. But that also has a variation, and we're in the section now for the next couple 33-year sections where that augmentation is not so severe. So it isn't going to be like we saw it till the end of the century. Oh, shucks.
All
So
right, so
this
we've got,
third question right here, do we think this one's acceptable? I kind of changed it a little bit based on what people said. Um, but I'm not sure what does everyone think?
I think that's good. And I think for the first one, and again, for this one, you might just have parentheses, meteoroid size, comma, velocity, comma, material, comma, structure, comma, anything else we could think of, and we may be able to determine some of this stuff and maybe not. Because you
Gotcha.
can have something, so the comets have different kinds of rocks in them. Sometimes the rocks are like igneous and they're strong rocks. Other times they're like sandstone and they break apart really easily. So surely that has something to do with it. I don't know if we could find that out from somebody else. But there's lots of things, and one could say that we are going to try to measure the typical duration. So we're going to try to measure the region. We are going to try to measure the strength and hope that we can find things that they are correlated with.
Okay. And then for the fourth question, I put, can meteor scatter signals on HF provide valuable data for propagation forecasting?
Can I go back to that previous one about the strength? If you're going to be using MSK 144, there is some data in the structure of the way things are sent. A lot of the guys will use their grid square, but the standard format is to use a dB determined by the software itself. So you can use the dB numbers if everybody decides to use dB, and you should probably suggest to those that are participating that they transmit their in such a way that they're using dB and not grid. You have two options there. You can start sending the contest mode, which is the grid, and people like that because they know right off the bat where they are. But the dB mode, where when a report is sent, it's in dB. You can use that for intensity variation. So that would be a helpful metric to use. And the second one, you will notice that the length of the burst is also a part of the data structure. So you can tell and it's in milliseconds, I believe. So those are the two bits of information that is available, and the WSJTX MSK 144 software, that mode.
Thank you.
Not being familiar with MSK 44 yet, but I've got it up on the screen here and really encouraged to have a play with these things. What happens where the duration of the MSK 144 contact is shorter than the duration of the trail? Your measurement will not really give anything valuable about the duration of the trail, will it? It'll be a function of the, unless we're looking at consecutive QSOs.
You can send a full stream of data, your call, your grid, a CQ, your call, your grid, in 250 milliseconds. That means if the burst lasts in more than 250 milliseconds or increments of 250 milliseconds, you get a pretty good clue as to how long it is. If you know the velocity of the meteor, that particular shower, typical velocity maybe X number of thousands of kilometers per second, you can compute the length that you had, length of that trail, where you actually copied signals. You can see where you started copying, where you lost it, and you can use that data for determining maybe how long the radian was, or the part that was ionized that gave you the signal.
Sure. Yeah. Okay. Thank you for that. And then the final point about the provision of HF data for propagation forecasting. I could think of one angle that the relationship between meteor input and sporadic E, so that the relationship between sporadic E activity, although it's not a very well proven thing, it's sort of fairly generally accepted. There's a big contribution from the meteor volume that these sporadic E patches are composed of. So the ionization there is a large part of it. So in that sense, this sort of material, this data, is quite valuable for sporadic E forecasting, and allows perhaps a more rigorous exploration of some of the other factors outside of the meteor input, which may not have changed or may have changed between different episodes. So I'm quite intrigued by question number 4.
I would wonder if we should take the word valuable out.
Yeah, well, we don't know, do we, yet? No, that's absolutely it. Yeah.
Yeah, I agree. Taking the word valuable out makes it a little more generic, but also I think Mackenzie, as Jim suggested, maybe parenthetically say, for example, one of the examples of the propagation information we get may be relationship or sporadic E to meteor scatter relationship. That's, I think, what Jim was saying.
Yeah, one final point just occurred to me when you were speaking is that one thing that isn't widely sort of understood about sporadic E and the meteor link is what the time delay is between, say, a peak in a meteor shower and any uptick in sporadic E activity off the back of it. So how long does it take for this fuel to become available for sporadic E mechanisms? And is it solely a function of the meteor delivery profile, or have we got to look very much more closely at the potential for triggering that into convergence into E's patches?
A lot of the E patches are triggered. One of the elements that's involved is wind shear.
Yeah,
there's
exactly.
quite a bit. So that's that also enters into it. And you'll see in the summer of the month, you'll see peaks during June, July. If you look at the wind shear, everything is more favorable for the June, July, and it's by August it really tapers down. So wind shear is another element in that. But yes, the iron content and the meteorites do have an effect on the development of the E layer. And again, the burnouts that we see from meteorites are generally in the what we would consider the altitudes of the E layer.
Yep.
Anyone else have anything for number 4?
I made a
before I go to five?
comment, Mackenzie, and meteor scatter was pretty exhaustively studied by the military in the past, and they've kind of gone away from it because of all the other reliable communication forms these days. But my thinking is that number 4, from a research standpoint, has probably already been thoroughly looked at. But I may
Okay.
be wrong on that, but I'm just throwing that thought out. It may or may not be a good use of our time to do that.
But I think it's
Hmm.
interesting just to put it in there.
Okay. I'll keep it in then for sure.
Yeah. And it's worthwhile. I did some looking on the military side, but and not very much. But there's a large body of data out there on military use of meteor scatter, although some of it may not be readily available. So whether we can figure out something there that's different or unique is a big question in my mind. So I just throw that out.
Maybe you could look up some of that stuff or tell us what they learned and next time or something.
Right, and I will step on the mic here again. It's John Campbell, W3MHZ. The military usage is, I got my call sign from my father, and he worked on that a lot. And it very much helps with military usage on the scatters. I have looked up a lot of the papers on that, and I have some of them. One of which I've sent to Mackenzie on the chat. So I will stand by.
Anyone else for number 4 before I go to 5? Okay. And then our last question. I just added this recently. What is the geographical extent of the ionospheric region influenced by meteor scatter at HF frequencies, and how long do these effects persist? Kind of a wordy one.
That should go up the top.
Number 1?
No, as a heading. And then
Oh,
under that, 1, 2, 3, 4.
okay. Let's see if I can do that right. Oh, gosh. Right below this, right here. How's that, Mary Lou?
Yeah, that looks good.
Here? Okay, let me fix this so it's not underlined. Okay. And then the 1, 2, 3, 4.
All right.
Okay. There we go. What does everyone think?
Part of that,
Any
that
comments?
one that you just highlighted is known. We know that the burnout occurs between 90 and 140 kilometers. That's the E layer area. Question is, as the burnout occurs, let's look at it looking west, left to right, or from right to left as a meteor is coming, depending on the shower, from the northwest to the southeast, for instance. If for those folks up in New England, typical Perseid meteor in the 11, 12 o'clock will start in the northwest and in the northeast. You can check the duration of it by the meteor burn itself. How long did it last? You know the speed of the typical meteorite for that particular shower. You can then compute, uh, assuming it's at the midpoint, and you hear a station on the other end. You can then compute what is the distance between the farthest right side of the burnout to the farthest left side as you're looking west, and that'll give you a mileage which you should be able to compute. And you can do that for many meteors. The problem is the meteors don't cooperate, and some of them will burn out before they make the entire right to left path. So you'd have to copy quite a few meteors and uh, note the burnout times and when it started, when it ended. But you could get some data from meteor burnouts to answer part of that question.
Mhm. Okay. Gary, that was all the questions that I had written up here.
Yeah, I think it was important that to get everyone's input on that today, and then hopefully we'll get some more from the workshop next week as well that I can feed back to you. Okay, do you have any other questions? Wanted us to look at anything else on your poster? It's looking pretty good. And Mary Lou suggested some more graphics, I guess, but
As was mentioned, there are quite a few articles on how to run Meteor Scatter. I suggest look at the one, do a Google search for how to do Meteor Scatter with WSJTX. How to do Meteor Scatter with
And
WSJTX. You'll find a,
Mackenzie, when you
say again? Yeah, you'll find one by K5 November Delta. Read that over. It'll give you a pretty good clue how it works and what it takes to get going. And you might discuss this and see if it make for those who haven't done it before, if it made any sense, or if it didn't have enough of the questions answered by reading that article. And again, everybody should download the user's manual for WSJTX. Go to section 8.5. 8.5 describes meteor scatter, the MSK 144 mode.
and Mackenzie, if when you get your slide updated, if you could send a copy to Ben, and we will check K5 November Delta. And
Okay.
thank you.
Yes.
Thank you very much.
Yep. Of course. Gary, you want this done by Monday, right? Just double checking.
right, yeah, I'm going to put out the note today asking everyone for their posters so we can get them to the print shop on Monday. So it'd be kind of
Okay.
like the end of the night, Sunday night. And that
then
way we
like-
can send these to the print shop in Newark on Monday morning, and we'll have them all for Thursday for sure.
Lucky you, Mackenzie.
Does anyone have any other suggestions that I should change? Maybe any deletions of figures, or I mean anything overall just to add to this? What does everyone think? I think these two are pretty good. I can add some more, like Mary Lou said, but maybe make it less wordy, I would say.
I don't know,
Or is it good?
I really like the picture I found with the 3 streams within the Perseids. I thought that was an interesting thing.
In other words, that's the kind of data we may be able to tease out of whatever experiment
Right.
we run.
That's the sort of thing that's possible for us to duplicate. All right.
I can stop sharing, Gary.
Yeah,
There you
that's
go.
fine.
Okay,
That's good.
there we go.
Well, great. We got a lot of input. I think a lot of very valuable input. It's a little after 5, we're about done for the week. Any questions or any last burning issues, or especially any questions related to the HamSCI workshop next week that we get answered? We'll be posting the link for people who want to attend virtually, hopefully by, well, I'm thinking Wednesday or Thursday of next week, a few days, just a few days before the workshop. And we can get a lot of virtual participation as well.
Okay, well, thank you. I just wanted to thank you again on Pat's behalf and my behalf, and especially you, Mackenzie. Okay, thank you.
Now, this experiment, the series of experiments, I guess you call it, is not hopefully going to provide us some valuable information, but I think it's been quite a learning experience for a lot of people. And I think as I think Joe said, the expansion of MSK to 10 meters is something new and different. And I think we can leverage that pretty well with the help of a few of you guys and all your contacts throughout the Meteor Scatter community. So I think a lot of different parts of this are going to come together to make it a whole, which is very satisfying to watch. All right, any last minute comments? Otherwise, we'll close it for the week. And of course, we won't have a meeting next week. A lot of us will be traveling to the conference in Newark, so the participation would be rather low if we did have it. So we'll take a week off next week.
Hey, Mary Lou, I sent you a chat if you get a second to look at it, okay?
Okay.
It's just for that presentation, so. Hey, Mackenzie, that looks so nice. Really, really well done.
Yeah.
Thank you.
Thank you, Mackenzie. Thank you all.
Thank you.
Yeah, very, very impressive, Mackenzie, and thank you, everyone.
Thanks, Nathaniel.
You're welcome.